is we want to try to find whether the results we have, are they within these limits of negative 2.5, positive 2.5. Please pay attention. Please, these are, of course, together they're 0.5. So let me just forget about that. Just worry about the idea that you want to know if it's within these red areas. If your numbers come out within these red areas, then it is significant. Any value that's within this big bell curve here, it can happen by accident. It can happen because of whatever is going on. It happens all the time. If it's in the red, there's something going on that we need to get our attention to it. So, how do we do this? We take chi-square, which is, I wish people would stop with the side conversations, and you know who I'm talking about when I say people. I don't want to embarrass anybody, because I'm recording this. We take the observed minus the expected, and we square it. Then we divide it by the expected. Why do we square it? To get rid of any negatives. We don't want any negatives in this. And this, of course, this Greek letter means sum. So add them all up. That's it. And you've done that. You see the table's done it for you. They do a great job with the table. Now that is a chi-square. Chi-square is not, chi is a Greek letter. It is not the square of anything. You can't take the square root of chi-square, so don't do that. Chi-square is a number. It's some number. In this case, you all calculated for your example 2. That is 2. Now how many different possibilities did you have? So you had total possibilities.
Are we finishing this tomorrow?
No. Possibilities of 2. It's either heads or tails. That's 2. So what's the degrees of freedom? Degrees of freedom equals 1. So 1 I calculated. I calculated. 2 I figure out the degrees of freedom. 3 I go to 0.05 on the table. You're always going to have a table. Yes. Find the critical value at your degree of freedom. That's it. In this case, in this example, with the degree of freedom of 1, with the chi-square of 2, in this case, the critical value we're going to compare to is 3.841. What that says is that this number here is 3.841. What it's saying is if your value is smaller than 3.841, then it's part of the average possibility. We're not worried about it. So if your chi-square is less than your critical value, you accept the null hypothesis. In other words, any difference you see is due to chance. If chi-square is greater than your critical value, I'm going to put CV, then you reject the null hypothesis and accept your hypothesis, your alternative hypothesis. And I should say, greater than or equal to, I guess. I'm not sure it really matters if it's equal to. I don't think I hardly think it'll be equal to. Hardly will come up. So anyways, that's it. It's just 4 steps. That's all it takes. That's it. That's all there is to it. And all they're saying is, look, guys, this number, this critical value that you got off the table is moving this line back and forth on that bell curve. Your value is, if your chi-square is smaller than this, that means that it's over here in the average. That means you can ignore it. It's due to statistical noise. Are we all good? Is that simple enough? All right, that helps. Did that help, Carlise? All right, so that's it. I'll post this. 5 minutes.